Example 3, we have construct a truth table for not P and not Q to determine when the statement is true and when the statement is false. All right, so I'm going to show you how to build this. So we're going to start off with our two statements, P and Q. I'm just going to draw a longer line here. So our four possible combinations for P: T, T, F, and F. And then for Q, we're going to alternate. TF, TF. This is going to be your standard. Now, however you want to write the combination, you're fine, is okay, but I would recommend learning this. Very easy. Okay? Now, what we're going to do here is construct the, of course, the truth table for each simple statement, and then our last statement that when we put it together, we're going to write out the not P and not Q. So my third column, I'm going to write, okay, the negation of P. So what will be the negation of P here? False, false, true, true. Then write the negation of for Q. False, true. What's that? False, true. Okay. And if you have to, and this is what I do, that until I learn what does the conjunction mean, until I know it by heart, and what does disjunction mean, I'll write it down. I see that connector of and it says for and, both statements must be true for it to be true. Okay. So lastly, so we've looked at each simple statement, P and Q, not P and not Q. Now our last column, we can go ahead and write out the question because we have it set up here. Okay. So we have false and false. What would that yield? Right. False and true. False. True and false. It's still false because for and, both components must be true. So our last statement here. T and T? True. Okay. So we want to determine when is the statement true. Right. It's true when both components are true. And we can say both simple statements are true. Not too bad. What do you think? Not too bad. Okay. All right, let's look at example 4. And we know otherwise then the other components for example 3 is false. Example 4, it says construct a truth table for, in parentheses we have P and not Q, then or not P. So we have a lot going on here. All right. So let's start off with P, our two simple statements, P and Q. So we know the foundation, how we're going to write this out. Start off with it. So inside the parentheses, we have P. So we really don't need to write another column for P because it's already there. But let's write a third column for not Q. It just makes it easier to read if you go in the order in which you see it, reading this from left to right. So we know not Q is FT, FT. False, true, false, true. Negation, not. The opposite. All right, so let's do what's inside the parenthesis. P and not Q. So, and meaning both components, both simple statements must be true. Okay, so here we go. We have TF, TT, FF, false, and then FT, false. Okay. We have or, we'll write that out last, and then we have not P. And we know not P. False, false, true, true. Our last column. Or is false when both component statements are false. So here we go. We have false or false. True, T or F, F or T, true, and then F or T, true. Okay, so it says determine when the statement is true and determine when the statement is false. Well, we know when it's false. Okay. Just to kind of put this all together. Okay, only is false only when both component statements are false. Otherwise, the statements are true. Example 5. Construct a truth table for P and not P to determine when the statement is true and when the statement is false. Well, just P. The 4 combinations are, help me out, true, true, false, false. Well, we know not P. Our statement here, P and not P. And true only when both are true. So do we have any component statements where both are true? No. Therefore, all of the components here are false. Each statement is false here. There we go. And you see me draw 3 dots like that, and I don't know if I told you in this class that in math it represents therefore. This is the shortcut, okay? All right. Any questions?